Mediation system can perform all these activities on CDR's files. Depending on our business requirement, we can use mediation functionalities. It is completely business decision whether we need to use mediation software or not, as it will increase the cost of the license and maintenance. That depends on the other factors like subscribers count and number of services and data flow and feature business integrations or acquisitions. In some cases, if we are not using all these features, we can also use pipeline for some of the mediation activities. Note, please refer OBRM pipeline estimations and implementation videos from KBC Technologies. Let's assume we got all these CDRs from mediation system. Now we need to process for rating. First, understand ways of implementation the OBRM system. First way of implementation or default way of implementation.
OBRM, portal is not a single product. Combining two products we call it as OBRM. First one is Portal Infranet, which is used for real-time rating. Second one is Portal Pipeline, which is used for batch rating. For each product installation we need two dedicated servers. For Portal Infranet product installation we need two dedicated servers. One is for application server, which is used for Portal Infranet software installation. Second one is for database server, which is used for installing Oracle software to store Portal Infranet data. For Portal Pipeline product installation, we need again two dedicated servers. One is for application server, which is used for Portal Pipeline software installation. Second one is for database server, which is used for installing Oracle software to store Portal Pipeline data. In our current scenario we are considering total two products installation. For this we need 4 dedicated servers, 2 servers for application servers, and 2 servers for database servers.
In this default implementation, we are using 2 different application servers and 2 different database for both products. We can implement both application servers in one server and both database servers in single database server. This will reduces the cost of the hardware and improve the performance. Also, database failures or database unavailable issues at the time of sync. Note, please refer pipeline performance tuning and database performance tuning videos from KBC Technologies. Second way of implementation. As we already know, BRM is not a single product. In this implementation, we are going to install both application binaries in one server and database scripts in a second server, that is OBRMDB server. In application server, we need to create user for real-time, create user, pin. And for batch rating, create user integrate. Once OBRMDB is ready, we need to create 2 schemas, that is Oracle users. One for real-time, that is pin. Second is pipeline user, that is integrate. Then we need to install DB scripts specific to both the products. Note, OS environment creation and OBRMDB database creation. Please refer OBRM application server and database server implementation videos from KBC Technologies. To create pipelines for retail, roaming and interconnect, we need to collect following details related to database users. 1. From real-time, following database details need to be collected from database. Database name /SID, database host, username, password, port number. 2. From batch rating, following database details need to be collected from database. Database name /SID, database host, username, password, port number. Note, these 5 parameters are used to connect to OBRMDB. Login to integrate user on OBRM application server. And install pipeline packages. Once you install pipeline software, the following folder structure will be created. To create pipeline, we need 1 registry file. In our example, we need to create 3 registry files for all 3 pipelines in config folder. Example, 1. Retail.reg, 2. Roaming.reg, 3. Interconnect.reg. Pipeline will be created by reading this registry file structure. First, let's understand pipeline architecture, how it will be created in RAM, that is random access memory. Let's understand about registry file. In pipeline framework, the registry file plays a crucial role in defining and configuring the processing of data through the pipeline. The registry file is a foundational component in the OBRM pipeline framework, providing the necessary configuration and control over how data is processed, transformed, and managed through the system. Pipeline configuration. The registry file acts as a central configuration file for the pipeline. It defines the sequence of pipeline stages, the modules to be loaded, and how data should flow through these stages. This configuration is essential for customizing the pipeline to meet specific business requirements. Module definitions. The registry file specifies which modules, e.g. rating, discounting, mediation, are to be used in the pipeline. Each module has its own set of configuration parameters that are defined within the registry file, allowing for fine-tuning of the module's behavior. Data mapping and transformation. The registry file contains mappings that define how data is to be transformed or mapped as it moves through the pipeline. This includes defining how input data fields correspond to output data fields, which is critical for accurate data processing. Performance optimization. By configuring the pipeline through the registry file, performance optimizations can be achieved. For example, certain modules can be bypassed or optimized based on the data processing requirements, ensuring that the pipeline operates efficiently. Error handling and logging. The registry file often includes configurations for error handling and logging. This is important for monitoring the pipeline's operation and troubleshooting issues when they arise. Proper error handling configurations can ensure that the pipeline continues to operate smoothly even when encountering data anomalies or processing errors. Extensibility and maintenance. The registry file makes the pipeline framework extensible. New modules or stages can be added or modified simply by updating the registry file. This makes the system easier to maintain and adapt to changing business needs without requiring significant code changes. Version control. As the registry file controls the pipeline configuration, it is often subject to version control. This allows for tracking changes over time, rolling back to previous configurations if needed, and maintaining a history of changes for audit purposes. Note: without registry file entries, we cannot create pipeline. Starting Pipeline Manager. You start an instance of Pipeline Manager by using the following command from the pipeline_home directory. Use the following command to start Pipeline Manager, ifw retail.reg. By reading retail.reg file, it will create memory structure in RAM. It will load the following plugins. 1. Input plugins. 2. Functional plugins. 3. Output plugins. 4. Data plugins. Input plugins. Their primary function is to read data from different sources and convert it into a format that can be processed by the pipeline. These plugins are customizable to accommodate different types of input data formats, such as 1. File-based input, reads data from files, such as flat files, CSV files, or other formats. 2. Database input, retrieves data directly from a database. 3. Stream-based input, consumes data from streaming sources like message queues or real-time data streams. 4. Custom input sources, handles data from custom or specialized sources that aren't covered by standard input types. Let's consider current example scenario. We are using file-based input that is CDR file. Let's understand how input plugins works. Data collection. The input plugin collects raw data from the specified source, example, files, databases, or streams. Parsing and validation. It parses the raw data into a structured format, such as records or events, that the pipeline can process. This may include validating the data against specific rules or schemas. Data transformation. The plugin may also perform initial transformations on the data, such as converting units, normalizing values, or filtering out irrelevant data. Forwarding to pipeline. After processing the input, the plugin forwards the data to the next stage in the pipeline, which could be rating, discounting, or any other configured stage. This is the CDR file which we received from mediation system, and we need to rate the CDR. This input module will read this file and load the data into memory to process the rating and discounting functionality. Input plugin modules are having a component called EDR Factory. The EDR Factory in the BRM pipeline is a specialized component responsible for creating and managing EDRs throughout the data processing stages. The EDR Factory essentially serves as an abstraction layer that handles the creation, initialization, validation, and management of EDR objects in the pipeline. This EDR Factory is responsible allocates and deallocates memory for EDR container. This EDR factory creates EDR container memory location by considering the format defined in the input format description file. Once memory is created, EDR container, it maps raw input data, example, CDRs, usage records, into specific fields within an EDR object. This includes interpreting the input data format and correctly parsing it into structured EDRs that the pipeline can process further. Before processing, the EDR factory validates the data in the EDRs to ensure it meets the required format, contains all necessary fields, and is free from errors or inconsistencies. This validation step is crucial to prevent faulty data from entering the pipeline and causing errors downstream. Note, the EDR factory allows customization for different types of events or usage records that might require unique processing logic. For instance, different types of EDRs, such as voice calls, data sessions, or SMS, may have different structures and validation rules, and the EDR factory can handle these variations by using custom EDR definitions. To understand this implementation, please refer to EDR rating process POC videos from KVC Technologies. In short, input plugin reads the incoming CDR. It converts incoming CDR to internal EDR format using format description files. It puts data into relevant fields of EDR container. Input plugin FWD the EDR container to functional plugin. Functional plugins access and modify the data from EDR container. It uses data plugins to access data preset in memory. Functional plugin modules performs pre-processing and rating operations. We use DBC plugins for database connectivity. Note, we need to use each database connection, one DBC plugin, or each schema, DB user, one DBC plugin. A DBC plugin in the pipeline manager is used to connect the pipeline to an external database to retrieve, update, or insert data during event processing. This allows the pipeline manager to access external data sources, such as customer information, rate plans, or usage details, which are not stored in the standard BRM database. The DBC plugin provides the functionality to perform database operations directly from the pipeline during event processing. Let's take two scenarios as we already discussed different implementations. First one, consider we have two databases, one is for OBRM database, second one is integrated DB for pipeline manager. DBC_plugin 1 is connected to OBRM database, and second DBC_plugin 2 is connected to integrate database. Output plugins. Output plugins handle the export of processed data to different formats or destinations. This can include exporting data to flat files, XML, databases, or other systems. After rating and charging, after completion of function modules, output plugins can generate billing records, invoices, or summaries that are stored in a format suitable for billing or financial processing. It uses configuration data description files for converting output format. Output plugin reads the EDR format and converts into output format. There are several types of output plugins. 1. File output plugin writes processed data to files, example, CSV, XML, JSON, on the local file system or a network location. Typically used for archiving or integration with systems that consume data from files. 2. Database output plugin directly writes processed data to a database table. This is useful when the processed data needs to be stored in a relational database for further analysis, reporting, or integration. Commonly used to update the BRM database or any other external database. 3. Custom output plugin allows the creation of custom output logic to handle specific requirements that are not covered by the standard plugins. For example, sending data over a custom protocol or to a proprietary system. Typically developed in C or C++ using the Pipeline SDK. Let's drill down deeper on each component in pipeline management and its configuration details on upcoming videos. With this slide, we just covered only an outline of the pipeline management architecture. Note, POC videos, please contact KVC Technologies business sales team.